Hey guys, how's everything going? This is JSer, who is not good at algorithms. Today, let's look at 173 binary search tree iterator. We're implementing an iterator over a binary search tree. Our iterator must be initialized with the root node of a BSD. For what is BSD? BSD means smaller nodes to the left and bigger nodes to the right. Calling next will return the next smallest number in the BSD. Like this. For this tree, we create a iterator, and next will return 3, next 7, has next, of course 2, next 9. Well, of course, so I think it's just first, let's forget about next and has next thing. What's the order? So how could we represent this binary tree in ascending order? Well, of course, it's inorder traversal, right? If we do it in a inorder traversal, we could store the nodes in an inorder form in an array, right? If we got this array, we can just keep an internal index, which means current index, and then next to next has next will just be some basic operations on an array. Well, right. Well, and everything could just be done. So let's start. So, how could we do the inorder traversal? Well, of course, we walk, right? If we'd like to use recursion, well, it's simple. Let's try to do that first. Use recursion. Well, we walk to the root. And then what should we do? The result, right? The result is like this, and then for one tree there will be only one array, so we don't need to create a new array, and we are going to use the inorder traversal. So we need first, if root has left, we walk. Not root, node left, right? And if there's no left node, and then it should be itself, right? So this is the how to say it? This is the array AR push node, and then if node right, we walk node right. So for 7, we walk 3, there's no left, so we push it, there's no right, and then we return, right? So we got 7, and we push it. So this is the, well, it's done. So we say this inorder would be walk roots empty. So this is the inorder one, and this index, I say current -1, right? So now we get next, which is simple. For next one, we will move the cursor to the next one, right? So this current plus equals 1, and then we return this inorder, this current. Well, this is done, and this is the current next. So if this current is equal to you may assume next call is always valid. That is, there will be at least next smaller number in BS when next is called. So there's no overflow check. If this equals to this inorder dot length -1, return false, return true. Well, this is done. Surely it's not. Huh? Cannot really push up undefined. Undefined? Oh, my bad. I should do this. This in order undefined? Oh my bad. I forgot to return. My input is why there are strings. Next. Oh, this is the input, right? Oh, okay, this is the input. This is the input. Wow. We just push my push node val. Should I keep the node or value? I think node is okay. Just return this in order and the val. Cool. Let's submit. If it is empty, wow, man. Okay. What happens when this is empty? If no left, no. Itself is empty. Okay, add this. Still not okay. God, no, my bad. If node equals null, I just say return empty. Not return empty, but return AR. No check. Cool. So I think there's nothing to be special about this one, so I'll end here. I hope it helps. See you next time. Bye bye.